Today's lesson is very similar to yesterday's lesson, except I'm going to try to apply what you've been learning to something. We've been talking about slope, we've been talking about rate of change, and what I want to tell you is that when we talk about the rate of change of something, we're talking about how fast something is going, or how fast something is changing, or how fast something is moving. That represents velocity. Now, if you've had physics, you might know the difference between speed and velocity. If you haven't, that's okay. Speed and velocity are very, very similar. We understand that speed, if you're driving a car and you go 50 miles per hour, that's the speed. Well, velocity is also 50 miles per hour, but it includes the direction. So if I am going from the school to home and I travel at 50 miles per hour, the speed's 50, but the velocity would be 50 toward home. And if home is like we're at the starting point, then toward home might be negative. If school is the starting point and we go toward home, then home would be positive. So velocity has positive or negative because it also tells you the direction that you're going. So when I say I'm going negative 20 miles per hour, that means that I'm going 20 miles per hour, but I'm going in the opposite direction. Usually it's left or down if it's something that's on the graph. And the way that relates to speed is that speed would be 20 miles per hour. Now, with calculus, because we do know things about positive and negative slopes, when we talk about rate of change and velocity and speed, we're normally talking about velocity. Now, if I ask you to find velocity, basically I'm asking you to find the slope or the rate of change, including the negative if there is a negative. If I ask you to find speed, then you would find velocity and then you would change the sign to a positive if it's negative. So, because velocity is represented by rate of change, let's do this problem. Okay, so if I want to find the average velocity between x equals 1 and 3 of this table, notice that I'm given some more information. X is in seconds, y is in feet, so that's really important as I'm trying to find the velocity. I do need to have units since this means something. So I'm trying to find it between 1 and 3. Remember that this just represents slope. So it's just like what we've been doing. Start with the y's, 10 minus negative 2 over 3 minus 1. You get 12 over 2, which is 6. Now, the thing about velocity or average velocity, you should say units since we have them here. We divided the y units first, so it would be feet and then per second, since the top was feet and the bottom was seconds. All right, the instantaneous velocity is the velocity at a point. So what you do there is you find, like you're estimating, and since this is the table that we're estimating, we're going to find the slope on the left, we're going to find the slope on the right, and then average. So for the slope on the left, I'm going to start with 0, so it'd be 0 minus negative 2 over 2 minus 1, 2 over 1, which is 2. The slope on the right, I'm going to start with the 10. 10 minus 0 over 3 minus 2, which is 10 over 1, which is 10. So then to find the actual velocity I'm looking for, I'm going to add and divide by 2. So I get 6, and then again, don't forget the units. It just happened to be the same. It won't always be the same. Okay, on this problem, let's say that we want to find the average velocity between x equals negative 2 and 1. Let's go ahead and give it some units. Let's say y is in miles and t is in minutes. So if I'm trying to find average velocity, again, we need the x and the y. I normally just make a table sometimes. So I'm going to plug in the negative 2. So it'd be 2 times negative 2 squared. So that'd be 8 plus 5 is 13. Plug in 1. So that would be 2 times 1 squared plus 5, so that would be 7. And then I'll just find the slope. I'm going to start with the 7. 7 minus 13 over 1 minus negative 2. And again, you could start with the 13, but just make sure on the bottom you start with the negative 2. So that would be negative 6 over 3, which is negative 2. And we divided, the y's were on top, so the y units are first, and then the x. Alright, if I want to do instantaneous velocity, same problem, instantaneous velocity. Then this is where we estimate. So we have 2. We want to go 0.001 around 2. So that would be 1.999 and 2.001. And then we would plug in those values. And I'm plugging it in the calculator right now. And I'm just going to put 12.992, but I'm going to remember that I'm using that whole decimal from the calculator there. That's not right. I think that's 13. I forgot a parentheses when I was putting it in. I shouldn't have had to put that in. Alright, then I plugged the 2.001 in. And again, I'm going to use that whole decimal. I'm just writing down a little bit of it, but in the calculator, when I find the slope, I'm going to use the whole decimal. So I'm going to start with this one, and I'm going to find the slope on the left. And I'm using the whole decimal from the calculator. So 13 minus the 12.992002 divided by 2 minus 1.990. Okay, and then the slope on the right, 13.008.002 minus 13 divided by 0.001. You can kind of look at it and tell what we think the estimate's going to be. But if I round it to 3 places, it might not be exactly right. So just be really careful about that. It does look like their estimate of our velocity is going to be 8, and then we keep our miles per minute like we did in A. Alright, last problem. This is another put in increasing order problem, and I know that the one we did yesterday was a little bit confusing. It was harder to tell, but I want to do one where it's a little bit more clear. So let's just think about it. Instantaneous velocity at 3. That means I need a little tangent line here at 3. Okay, at 2, that means I need a tangent line at 2, because remember that instantaneous velocity is just the slope. So basically, I'm looking at the slope of those 3 things. And it's hard to draw on here, so I hope I'm drawing them so they can see them. And then 0 and negative 1, average velocity between 0 and negative 1, be that. And if you look at that, it looks like that it's just increasingly going up. So if I were going to put these in order, that one would be first. Instantaneous velocity at 1 would be next, and then 2, and then 3. If there happened to be one where I was saying the instantaneous velocity between 1 and 3, that one is very, very similar. So what you would do is it would be 1, and then 1 and 3, and then 3. Like if that was the choices. It would be f prime of 1, and then between 1 and 3, and then 3. Like if those were the things you were needing to put in order, just so you know, like the between one is always between the first and the last. And since all that was positive, that's the reason it's in that order. So, for the try problems, what I want you to do is, this is that worksheet that we have been working on. It's at the very bottom on the back. So I want you to do number 1 on the back, and I want you to do number 5 on the back. 1 should be really, really easy, not a lot of work. 5, we're still practicing with those common denominators, so I think you need to practice that, especially on the B part. I do want to tell you one more thing. When it says find the instantaneous velocity, we do not want to estimate. Estimating is only if it says estimate or only if it gives you a table. Finding is where we use our formula, the limit as h approaches 0, f of x plus h minus f of x all over h. Just like we found it up here where we found that formula, and then plug in the 2 to get the actual velocity.